So let's look at how we can use regression to come up with equations to represent data that we're given. So we're going to do in this video, a log regression. But first of all, let's look at the information we're given here. So sales of a video game released in the year 2000 took off at first, but then steadily slowed as time moved on. The table below shows the number of games sold in thousands from the years 2010 to 2020. So we can see that. Here's these years and how many thousands of games sold. And yeah, they've gradually slowed down. So lots in the first year, but then we're only up 7,000 the next, and so on. So it says let x represent time in years, starting with x equals 1, and y represent the number of games sold in thousands, and we're going to use a logarithmic regression to fit a model to this data. So the log model that we're going to use is y equals a plus b ln x. So this is usually the equation that we would use if we're going to have some logarithmic data. So remember, logarithmic data should look something like this, or it could look something like this. Okay, so we're looking for some data that has that kind of a picture to it. So let's put this in Desmos and see what we get. So if this is going to be 1, I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's actually 11 years of data here, so I will go and create a table and go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And the y values, there'll be a bit of flipping back and forth here. 142, 149, 142, 149, 154, 155, and 154, 159, 161, 159, 161, then 163, 164, 164, 166, 166, 167. Okay, let's close this so that's not going to be annoying anymore. Okay, so these would be the points, and they're plotted on the graph here, but we can't see them because our y value is only going up to 4, and they're much bigger than that. So let's shrink this axis down until we can see some points. There they are. So they're kind of having a curve here that's curving gradually up to the right. So we have an increasing log function. So now what we'd like to do is we'd like to put a regression through this. So we will go here and we will enter this in. So y1, and then we're going to hit that number underneath that character underneath the escape button, which is that little squiggle. So it tells us to do a regression, and we're going to use that same model. So that model was a plus b ln x. So a plus b ln, and then I'm going to put x1 in there so that it knows to grab this information from the table that I put in. So we've got we've got the equation in there. It's plotted the graph, which looks pretty good. It's going through those points pretty good. So I'm happy with that. So let's just see what it gave us for the equation here. It says A should be 141.912. That's that number, and B should be that number. Okay, and if you're wondering actually what this r squared is, that's just how close this is to being perfect. So if it went through exactly every one of these points, and you can see it's off by a little bit here and here especially, but if that was exactly if that was 1, then our graph would be perfect. It would go through all those points, but it's pretty close, 0.9934. So we got a pretty good match. So 141.912, 141.912 plus 10, 4, 5, 3, 7. 10, 4, 5, 3, 7. ln x would be our model for our particular function, where y is actually our population, y is the thousands of games that were sold, and x is the number of years. So if we were going to do 2025, then since we started at 2010 and that was 1, then this would actually be the 26th year. There'd be 26 more years because this was 1, 2011 was 2, this was 3, so we're 1 more than the actual number of the year. So I would put 26 in here for x to answer that question. I will get my calculator out, and we will enter 141.912 plus 10.4537 times ln of 26. Whoops, I can't use that. I got to use my ln button right there. ln of 26, which would be 175.97 thousands of games. So that's how we can use a tool like Desmos to create a log regression, to come up with an equation to represent some data that we're given and worked with.